All right, let's talk pH. So quick review. Acids taste sour. Our electrolytes, our conductors, like to react with metals, or a lot of them. Okay, on table K, we have strong electrolytes and strong conductors at the top, and weak electrolytes and weak conductors at the bottom. So strong acids at the top, weak acids at the bottom. And lots of foods are acids, but not all, so because they're in batteries, so watch yourself. Properties of bases. Well, they're bitter, they're slippery, they're also electrolytes and conductors. And a lot of them are cleaning supplies, hence the slippery part. All right, so table L has strong electrolytes and strong conductors at the top, weak electrolytes and weak conductors at the bottom. So strong bases at the top and weak bases at the bottom. In reality, on this chart, NH3 or aqueous ammonia would be the only weak base. The rest you can see all have OH and are paired with a group 1 or group 2 metal, so those are strong. But let's be real, strong versus weak is pretty vague. We might need to be a little bit more precise. So that is where today's topic comes in. pH. It literally means a measure of the hydrogen ion or hydronium ion concentration. So it's a measurement of how acidic or basic a solution is. And the values range from 0 to 14. So 0 the very lowest and 14 the very largest. All right, so here's what it looks like. 0, the lowest number, that is the most acidic. 14, the largest number, the most basic. 7 in the middle is something called neutral. All right, so in reality, as we get further away from 7 this way, the acid gets stronger. As we get further away from 7 this way, the base gets stronger. So again, neutral pH is what? 7. Right smack in the middle. An acidic pH is less than 7. So that could be 6.9. It could also be 1 or 0. It just has to be less than 7. And then a basic pH is also called alkaline. So of course, you know, if it's an acid, it's acidic. If it's a base, it's basic or alkaline. Great. Another word to remember. Fantastic. Anyway, sorry, I digress. Basic pH or alkaline pH means it's greater than 7. Now that seems simple, right? Well, guess what? There's also POH. Oh, great. What do I mean by that? It's really not so hard. So POH means it's a measure of the hydroxide ion concentration. It still talks about how acidic or basic something is, and its values still go from 0 to 14. Together, they make a whole picture. So pH plus POH equals 14. Okay. Now, when a solution is neutral, its pH is 7 and its POH is 7. So if something is a base, its POH will be higher than 7 and its pH will be less than 7. And if something is an acid, its pH would be greater than 7 and its POH would be less than 7, because no matter what, they have to add up to 14. So where do the numbers even come from? All right, well, let's talk about it. So how do we actually calculate it? So it's the negative logarithm. So these brackets right here that you can see, they mean concentration. So this means POH is the negative logarithm of the concentration of OH negative ions. And pH is the negative logarithm of the concentration of H plus ions. Well, guess what? We don't actually have to do the logarithm math. We just have to kind of know it conceptually. So let's look. So if I have a concentration of negative 14, okay, that means the negative times 10 to the negative 14. That means the negative logarithm would be 14. So what do you notice here? Okay, that means that if the pH is 14, okay, the pOH is going to be 0 because they have to add up to 14. If the pH is 13, the pOH is 1. So this means in reality that no matter if it's an acid or a base, there's H's present and there's OH's present. All that changes is the amount. So you can see a pH of 7, right? A pH of 7 came from a hydrogen ion concentration of 10 to the negative 7. pH of 2, concentration of 10 to the negative 2. So you can kind of see where the logarithm factor comes in. So let's look. This represents the OH concentration right here. All right, and you could see as the pH is increasing, the OH is going up. This representing H plus. As the pH is decreasing, H pluses go up. Well, I'm going to show this a little bit differently. Ready? Let's make a pH scale. So we have 0 to 14, we have 7 in the middle, we have the rest of the numbers. So I'm going to give you this visual, okay? This visual representing H plus or H3O plus concentration. You can see, where is this the largest? Well, it's the largest when the pH is 0. When the pH is 14 over here, it's itty bitty. All right. Now we pair that with the OH negative concentration. You can see when it's 14, there's a lot of OHs and barely any H pluses. So what can you see at 7? Well, the amount or concentration of OH is identical, equal to the concentration of H plus. But you can see, look at this, even at the pH of 0, it's mostly H pluses. We get a little bitty amount of this. So as we go this way, our OHs increase, and as we go this way, our H pluses increase. So let's look at some changes. All right, so here we have our chart. How much does the concentration of H plus change as the pH changes from 7 to 4? Okay, so here's the other part. Since it's a negative logarithm, anytime you make a jump of one number on the pH scale, the concentration changes times 10. It doesn't matter if we jumped that way or we jumped this way. If we jump one number, the concentration changes times 10. If we jump two numbers, well, this first concentration changed times 10, but 10 times 10 is times 100. So two numbers equals 100 times change in concentration. So let's see, we're going from 7 to 4. So we're going 1, 2, 3. That's where we're going. So because this is 6, 5, there's 4. So this jump times 10. This jump times 10. This jump times 10. 10 times 10 times 10 is times 1,000. So the concentration changed by a factor of 1,000. And what happened to the H pluses? As we go this way, there's a 1,000 times increase in H plus. We got closer to 0, so H pluses are increasing. When we go closer to 14, H pluses would be decreasing. The pH is 10. So let's see, 7, 8, 9. We're right here at 10. The H3O plus concentration increases by a factor of 100. So if H pluses are increasing, which way do I have to go? This way. By a factor of 100. Well, that's a factor of 10. There's a factor of 100. So my new pH would be 8. The pH is 7. So we're starting at 7. And the H plus concentration decreases. So which way do I go for decreasing H pluses? This way. By a factor of 10. There we go. So my new pH is 8. And that is pH. Hope you learned something new today.